Let's start with a new chapter, which is construction of geometrical figures and coordinate geometry. So we know a lot of geometrical figures, right? Like squares, triangles, rectangles, rhombus, parallelograms. We have studied a lot about them. Now, how do we construct each one of these figures? And here in this chapter, we'll learn about the construction of the geometrical figures, and also we'll learn a little bit about the coordinate geometry, right? Now, let's start with the construction of a triangle when all three sides of the triangle are given. Let's say we have to construct a triangle and we are given the data that we have a triangle ABC whose side AB is equal to 4 centimeter, BC is equal to 6 centimeter, and AC is equal to 5 centimeter, right? Now, we'll actually draw any line of, let's draw a line AB. This would be AB with 4 centimeter, right? Now, what will we do next? We'll take the side BC at 6 centimeter. So, this is B. So, we'll start from B and draw a line about 6 centimeter. So, we are drawing a line 6 centimeter from here. So, this is 6 centimeter and we'll name the other point C. And now, we'll draw a line from A to C, which is 5 centimeter. We'll keep a ruler and we'll draw all these three lines, and then we'll get a triangle whose sides are 4 centimeter, 6 centimeter and 5 centimeter. So this is a pretty easy construction. We just require a ruler and a pencil, right? Now let's move on to the construction of a triangle when length of two sides and an angle is given. So when we are talking about the congruence of triangle, we have different congruence to say that two triangles are congruent. We have SSS criteria, SAS criteria, ASA criteria, right? Now, here our two sides, the length of two sides and one angle is given, right? Now, first what we do is, we'll actually draw a line AB, right? We'll draw a line AB, which is of the given length. The length would be given. Now, we'll take a protractor. We'll place it over here, right? We'll place the protractor here, right? Now, this would show us the angles from 0 to 30 to, there would be markings on the protractor like this, right? Now, we keep the protractor here, 0 aligning to the point A, and then we'll find, say from A, the angle given is 30 centimeter or 40 centimeter, right? Or 40 degrees. Now, we'll draw an arc at 40 degrees. Around here it would be. So, we'll draw an arc around here, right? Now, we'll take a compass, right? We'll take a compass from here. If we are drawing an arc like this, we'll take a compass and we'll mark how much length is given, right? Now, we'll draw another arc. So, we take a compass, say that we have to take 3 centimeters. We'll put a ruler like this and then we'll place the compass over this, where if this is one hand of the compass, we'll place it over there and the other hand over there, and we measure 3 centimeter in compass. We'll place the compass here in the point A and we'll draw an arc, right? Now, we'll join both of these arc and we'll get a point here, which is C, and then we'll join both of these sides B and C. So, ABC would be a triangle, right? ABC would be a triangle whose two lengths and one angle is given. So, this is a method to draw a triangle with two sides and one angle given. Now, construction of a triangle when the measure of two angles and the length of one side is given. So, what do? One side is given, we'll take that side as the base. We'll take the side as AB. AB will be the side. Now, use a protractor to measure the first angle at a point P and draw it. Now, we'll take a protractor, place it here, we'll measure the angle, let's say 30, we'll draw an arc according to here. So, we'll put a point here, right? Now, we'll take a compass and mark here, right? Now, from B, we'll put the protractor here again, measure the angle which is given, we'll just mark it here, and with the same protractor length, right? I'll take a point from here, draw an arc here, and then we'll join these two points and we'll get a triangle whose one side is given and two angles is also given, right? Now we'll talk about the construction of a right angle triangle when one of the length and hypotenuse is given, right? So first we'll draw a line segment AB. AB is the given line segment. Now we'll take a compass and draw an arc with the length of the hypotenuse, right? The center of the arc should be at point A. Now we'll take a we'll put the compass here, the sharp side here, and then we'll draw a line segment, like we'll mark a length till here, right? So this is the length of the hypotenuse. With the given length of the hypotenuse, if the hypotenuse is given to be 7 centimeter, we'll take the 7 centimeter in the ruler from the compass. We'll take it in the compass. We'll draw an arc, right? Now, the center of the arc should be at point A. The center is here. The arc will intersect the line segment at B, AB at the point that is labeled as C. So, what will this happen? This arc will go on like this, right? Now we'll draw it from A to B and we'll draw a line segment which extends from here, right? Now if this intersects the line segment here, right, we'll draw it from here to here and this would be the hypotenuse. So this is how we actually construct a right angle triangle. Now let's move on to the next thing, which is the construction of quadrilaterals, right? Now what do we do to construct a quadrilateral? We have length of 4 sides and a diagonal given. So we'll take a ruler and draw a line segment AB, right? We'll draw another line segment of the second given length starting from point B, label it endpoint C. So we'll do the second line, right? Draw a line segment of the third length starting from C. So what do we do? We have 4 sides given and 1 diagonal given. So the diagonal should actually split the angle B into 2 parts, right? So we have AB and AC and we have C and D here. We'll draw all of these 4 things by taking the compass, taking the length, and we'll draw an arc here, an arc from here to here, and up from here to here. Now we'll have a diagonal across each other. So we'll put a point and we'll draw the diagonal, right? Now, let's move on to the next construction. This is the construction of a quadrilateral when 2 diagonals and 3 sides are given. Now, how do we do the construction of a quadrilateral when 2 diagonals and 3 sides are given? So, first of all, we'll draw the diagonals. First, we'll draw the side, let's say AB, and then we'll take the put the compass at A, we'll draw the one length of a diagonal from here and the other length of the diagonal to here, right? So this would be the arc of the diagonal 1 and this would be the arc of the diagonal 2 here. Now draw another line segment of the second given length starting from B. So we'll do, what will we do now? We have 3 sides given, right? So we drew the first side which is given here, we drew the length of the diagonal here, we marked an arc, and we'll mark another arc. Now there is one more length given, right? We'll take that length in compass and put an arc here and we'll join these 2 points and we'll name this as D, right? Now we'll take a point from here or either here. We'll take it from B and we'll measure out the length in the compass and we'll join those 2 and then we'll join these lines using a ruler. So here we'll get a figure which is a quadrilateral. Now we know the length of this one, right? We know the length of the diagonal and the length of 3 sides. Now, how do we construct a quadrilateral when 2 adjacent sides and 3 angles are known? So what do? We'll take a ruler, we'll keep it, we'll draw a line segment AB, right? Now, first we'll measure the angle at the point B. 2 adjacent 3 angles is given. So from here we'll put a protractor, we'll measure the angle. Now we'll mark the angle somewhere around here. What is the angle? We'll mark it. right? Without changing the protractor position, measure the second given angle at the point A and draw it. So we'll take what is given here, we'll draw the angle, right? We'll mark the angle. Then, so draw another line segment from point A with the length of the given side. So two adjacent sides are given. So one we took here and we know the second adjacent side. So we'll take the side given, we'll put a protractor, we'll draw an arc. Now we'll join the line in this angle through the arc, we'll get the second side, right? Now we'll name it as C. And now draw the third angle at the end point of the newly drawn line. Now from here, put the protractor here, we'll measure the angle, right? And we put an angle point here. We have an angle point here too, right? So we extend it, we extend this angle too. Wherever the both angles meet together, we'll complete the quadrilateral and name this fourth point as D, right? Now, construction of a quadrilateral when three sides and included angle is given. Now, first what do? We have one angle and three sides. First, we'll draw the baseline segment, which is AB. So first, let's see the included angle at B. We'll put the protractor here, right? We'll mark an angle. Then, how much sides are given? Three sides are given. Now, we'll put it at A. We know the included angle. So, we'll take one length from here. One included angle is given. So, we draw it from here, right? Now, we got A. So, when the second given side is also given, from A, we'll mark that. And the third would be drawn from here to here. You put an arcs with the measure and you draw it and you complete the figure. So, this is how we do the construction of a few triangles and a quadrilateral. Now, let's move on to the coordinate geometry. So, what is coordinate geometry? So, we know that we have different coordinate things, like when we are explaining a graph, we have x coordinate, we have y coordinate, and we have various different things like that, right? So what is there? What is this used for? So the Cartesian system, this system, right, what we normally see, this system where we have x and y is called the Cartesian system. The Cartesian system is way to represent points and location on a flat surface. Like if we have a two-dimensional surface, we use the Cartesian system to define the surface and to explain what is going on in the points in the system, right? Now we know that what is a two-dimensional plane, right? It have two axes to explain the location of the point, right? Now that's a two-dimensional plane. If we need 3 points to explain something, a point or a location of a point, that is called a three-dimensional plane, right? Now, if we only need one coordinate to explain the location of a point, it's called one-dimensional plane. So, in a Cartesian system is a way to represent points and locations on a flat surface, like a piece of paper or a computer screen, right? It uses two perpendicular lines called x-axis and y-axis. So, what do we have in the Cartesian system? We have x-axis here and the y-axis here. The points where these two lines meet is called the origin. So we have an x-axis and a y-axis which extends infinitely towards both sides, right? So we covered the x-plane whole and the y-plane whole, right? And now we have the point where they meet each other, which is at 0. We are imagining this, right? So that things would be easier. Now, the x goes left and right while the y goes up and down. This system helps us to give coordinates to the points, and we can use these coordinates to locate and describe different positions on the surface. So if I have a point here, let's say if I have a point here, what is this point? We actually write the points in a coordinate system like this. We'll put a circular bracket, x and y. First we'll write the x coordinate. The x coordinate of this point would be 1, right? And y coordinate is, we see what is the y coordinate. This is the y coordinate and this would be the x coordinate. So 1 is the x coordinate and 2 is the y coordinate. So 1, 2 is the location of this point, right? Now if I have to locate a point here, right? What is the x coordinate here? X coordinate is -2. And what is the y coordinate? Y coordinate is also -2. So this is how we explain the location of a point using Cartesian system. Now, Cartesian coordinates of a point, right? We just talked about what are Cartesian coordinates, the way we express it. In the Cartesian system, we use coordinates to describe the position of a point, right? The coordinates of a point are given as x, y, where x is the value along the x-axis, right? So the left and right distance is called the x. So when we are talking about x value, it actually says that how much far is it from 0, okay? How much far is it from 0 to the right, or how much far is it from 0 to the left? That's what x coordinates tell us about. Now, and y is the value along y axis, which is up and down. Again, it says that how much distance apart is the point from the 0 to the upper part or to the lower part. That's how we use y. We have y and minus y, and we have x and minus x. Now, for example, if a point is located 2 units to the right of the origin and 3 units up. So we have 2 units to the right and 3 units upwards. So we'll get a point here, right? That's 2 and 3. That's how we represent the point, which is 2 units right to the origin and 3 units up, right? Now, if a point is 4 units to the left of the origin and 1 unit down. So we have 4 unit to the left and 1 unit down. How do we write this? This is minus 4 and minus 1, right? Now, the negative sign indicates the direction from the origin. So we put the right is positive, so the left would be negative side. Now, if there is a positive side from upper side is the positive side, the lower side would be the negative side. Now, this is about the Cartesian coordinates of a point. Now we have quadrants. Okay, the Cartesian system is divided into 4 parts called quadrants. They are numbered as 1, 2, 3 and 4. Quadrant 1 is in the top right, quadrant 2 is in the top left, quadrant 3 is in the bottom left, quadrant 4 is in the bottom right. Each quadrant has a unique combination of positive and negative values for both x and y coordinates, right? So, what about these quadrants? So, we are taking any values, any points in this quadrant, we'll get x is positive and y is positive. Why? This is the right side and this is the upper side. So, this is right and upper side combined in quadrant 1. So, both x and y values are positive. Now, when we are talking about the second quadrant, right? When we are talking about the second quadrant, we are talking about the left side, right? For the left side, x would be negative because this is negative 1, negative 2, negative 3, negative 4, etc., right? Now, when we are talking about the y-axis, we are just still on the upper portion. So, we have positive y and minus x in the second quadrant, right? Now, when we are talking about the third quadrant, what we have is, we have negative values of x and negative values of y. So, we have negative values of x and negative values of y. So, third quadrant always contains minus x and minus y forms, right? Now, in the fourth quadrant, what do we have? The fourth quadrant is in the right, so x is positive, right? Now, it's in the bottom part, so y is negative. So, it's x and minus y. So, these are the 4 quadrants. You have to remember where is the first quadrant. That's the top right, right? Now, top left is second quadrant. Now, third quadrant is bottom left and bottom right is fourth quadrant, right? Now, we have to find the distance between 2 points. Let's say we have a graph. We have a graph here, right? Now, we have a point x1 and y1 here. This is x, this is y and this is 0, right? We have x1, y1 and we have another point which is x2 and y2 which is located some distance apart. So, we have to find the distance between these 2 points. Let's call this point A and let's call this point B. We have to find the distance between A and B. So, how do we find the distance between A and B? Let's see. So, what is the x coordinate of A? X coordinate would be somewhere around here and this would be x1, right? And y coordinate would be here, which would be y1. Now, when talking about B, this would go down and this would be x2 and y coordinate of B would be somewhere around here. So, this would be y2, right? Now, what is the distance of the point x1, y1 from the origin. That would be, what is the distance between these two? X coordinate, that would be x1 minus 0, right? So the distance is x1 from 0, right? And what is the distance of y? Y is this much distance, so y1 distant, right? That's what we say. So what is the total distance of the point from the 0? We have x1 plus y1, right? That's the total distance of the point A. Now, what is the total distance of the point B from 0 or origin? We call this 0 as origin. Okay. So, what is the distance of B from the point origin? We have the coordinates x2, y2. So, it's x2 plus y2, right? So, when we are talking about the distance of the point x2 from the origin, we are talking about this length, right? It's supposed to be a straight line, but yeah, we are talking about this length. Now, what do we have to find? We know the length of this one, right? And now we know the distance of this one, right? This would be actually not x1 plus y1. Why? Because x1 is this distance. Okay, let's make it a little bit more clear. This would be x1, right? And this would be y1. This would be x1 and this would be y1. This distance is y1, right? Now, what do we see here? We have to find this distance from the origin, right? So what do we get here? We get a right angle triangle. This would be x1, this would be y1. So what is the hypotenuse? It would be root of x1 square plus y1 square, right? So distance from origin to A would be root of x1 square plus y1 square according to Pythagoras theorem, right? So B from A would not be x2 plus y2. Instead, we have, we have another one which is, it just goes up to B. We have another right angle triangle here. We have to find this distance. This would be x2. No, this would be y2. Always vertical distance is y2 and the horizontal distance is x2, right? So in this triangle OB and whatever this point is, what do we have according to Pythagoras theorem? We have another triangle where this is x2 and this is y2 and this length would be root of x2 square plus y2 square, right? Now we have the distance of point A and point B from origin. Now what do we have to find? We have to find the distance between these 2 points A and B, right? So we have the distance OA, we have the distance OB, right? We have to find AB. So we could write that AB is equal to OB minus OA. How can we write that? Because OB is the longest line, it's the distance of this point from origin. Now we have another point A here, right? So we subtract this much distance from the whole distance OB and we'll get the remaining distance, that is AB. That would be the distance between the 2 points A and B. So AB would be equal to, what is OB here? OB would be root of x2 square minus y2 square, no, plus y2 square, and this subtracted from x1 square plus y1 square. That is AB. Now what would be AB square? AB square would be equal to x2 square plus y2 square minus x1 square minus y1 square. We take this minus inside and multiply with both of these numbers, right? Now we align the terms together. We have x2 square minus x1 square plus y2 square minus y1 square. This is AB square. Now what is AB? AB is equal to, let's say AB is equal to root of x2 minus x1 the whole square, right, plus y2 minus y1 the whole square, right? Yeah. So here we got that AB is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. So AB is the distance between 2 points, right? Now let's move on to midpoint. So we have a line between two coordinates. We have the point A and point B, right? Now this is a line. Now this point have a coordinate x1, y1, right? This have a coordinate x2, y2, right? Now the midpoint is the point which is exactly halfway between two given points. We have this line and the middle of the line, exact at the middle of the line, there is one point which is called the midpoint, right? So how do we find the midpoint? We take the average of each coordinates. So for x coordinate, we have x1 plus x2 by 2. So we'll get the x coordinate in the middle, and y1 plus y2 by 2 would give us the y coordinate in the middle. So we'll get a coordinate which is x in the middle and y in the middle, right? So this is the equation to find the midpoint of a line, that is x1 plus x2 by 2 and y1 plus y2 by 2. Now we have something called the section formula. The section formula is used to find the coordinates of a point that divides a line segment into the given ratio, right? Now to find the coordinates of a point P that divides a line segment joining two points A and B in the ratio m is to n, we use the section formula. So let's say we have a graph here. So this is just positive x and y, right? This is the origin which is 0, 0, right? Now, let's say we have a line. We have a line AB. The coordinate of A is x1, y1 and coordinate of B is x2 and y2, right? Now, I am saying that a point P divides the line in the ratio 1 is to 3. Like I am saying that it is dividing this line AB into the ratio 1 is to 3. That is AP is 1/3 of PB, or PB is 3 times the length of AP. It's dividing this line in the ratio 1 is to 3. So how do we find the coordinate of the point P? To find the coordinate of the point P, we have an equation saying that P is equal to mx2 plus nx1 divided by m plus n. This is the x coordinate, and we have my2 plus ny1 by m plus n. What do we have? So what is m and n? In case of this, m is equal to 1 and n is equal to 3. The ratio which is dividing it, it's m and n. And we have x1, the coordinate of point A, x coordinate of point A is x1, y coordinate of point A is y1, x coordinate of point B is x2, and y coordinate of point B is y2. So according to the section formula, we have the point which divides a line into a ratio m is to n, and the coordinates of a point is given by P is equal to mx2 plus nx1 by m plus n is the x coordinate, and my2 plus ny1 by m plus n is the y coordinate. So that's about this chapter. So in this chapter, we discussed about the construction of various geometrical figures, including a triangle when all three sides are given. Now we actually drew a line, and then we took the compass and we marked all the centimeters there, and we found a midpoint or the meeting point of two arcs, and then we joined it, we got a triangle. Now we have to construct a triangle when length of two sides and an angle are given, right? So we mark the two sides, and we measure the angle from one side, we mark the angle, and then we put an arc. So we draw a line which passes through the point we put for angle and that arc, right? And then we mark another arc from B, and then we join the line. And now we talked about construction of triangles when measure of two angles in the length of one side are given. So we'll take that one side as the base, and then we'll measure two angles and put the angles there. We'll extend both of that lines, and the point where it meets, right, we'll put the point C. Then we talked about the construction of a right angle triangle. Then we talked about the construction of quadrilaterals when the length of four sides is given and diagonal is also given. Then we talked about the construction of quadrilateral when two adjacent sides and three angles are known. Also, we talked about the construction of triangles when three sides and included angle is given. Now we've talked about Cartesian coordinates and Cartesian coordinate systems. We talked about what is Cartesian coordinates and what are Cartesian system, and we talked about how to represent a location of a point in a Cartesian system. We talked about quadrants and what are the values of x and y in each of the quadrant. Then we talked about the distance between 2 points and the formula for the distance between two points. We also talked about midpoint of a point and how to find the midpoint. And finally, we concluded with the section formula, that is, if a point divides a line segment into two in a particular ratio, how do we find the coordinate of the point? So this is all about the chapter Construction of Geometrical Figures and Coordinate Geometry. I hope it's clear.